So this is problem 51, chapter 13, Giancoli 6th edition. So the root mean square speed of molecules in a gas at a certain initial temperature. Okay, and let me assume here that this initial temperature is, I'm going to write it here, 25 Celsius. Okay, and we want this root mean square this root mean square speed initial, I'll call it 1, to be increased. So we want this new one, this 2 here, to be increased by 2.4%. So what does this sentence mean? That this new root mean square speed is the original one plus 2.4%. That is plus 0.024 of that original one. Okay, so this is the important thing in this problem, to understand this sentence. Okay, so that this new speed is the original plus increased by 2.4%. Okay, now given that, we want to know what is this new temperature, to what temperature these molecules have to be raised. So this is the question of the problem. All right, so let's remind ourselves what is the expression for the root mean square speed. We know that this expression is the square root of 3kt divided by m. Very careful, this temperature has to be in Kelvin. All right, K is Boltzmann constant, and the mass is the mass of this substance that we have. Very well. Nothing is changing here. No, we are not changing the number of molecules. The constant, Boltzmann constant, of course, does not change. So the only thing that is changing here is the temperature. Okay, so this new, so let me write in terms of this new speed, is equal to the old one plus that 2.4%. So it's equal to 1.024 of that old one. Okay, so this is the important expression. Now let me use the equation for this, the root mean square speed here. So what we have is 3kt2, because this will change, divided by m. So this square root equals to 1.024 3kt1 divided by m. See, so everything else is the same. The only things that are changing here are these temperatures. Okay, so how are we going to solve that? Well, let's get rid of the constants, right? So this 3k m, and now let's square everything. So we have that T2 divided by T1 is equal to 1.024 squared. T2 is what we want to find. This is our unknown. T1 we have, but very careful, we have to write the T1 in Kelvin. Okay, and now from this you can find your T2. Now, so maybe better to write it like that. T2 is equal to T1 multiplied by 1.024 squared. And remember this T1 written in Kelvin. All right, and so you're going to get your T2 in Kelvin. But careful, WebAssign wants you to enter the answer in Celsius, so don't mess up with Celsius and Kelvin. First, you have to write T1 in Kelvin, so you're going to get T2 in Kelvin, and then subtract 273 to enter your answer in Celsius.